Assalamualaikum and hello. Before we start our presentation, I would like to introduce myself and my team. Me, Nursyahira Binti Mohammad Zaidi, and my team, Nurul Amyra Binti Mohammad Hishamudin, Shakir Zufayri bin Shahrum Zamir, and last, Alia Natasya Binti Arif. So today, we would like to present about the design of material handling system for investment casting lab. So, let's start. For introduction, the product that we have chosen for this project, where it is specifically for lab casting, is called manual hand winch stacker. It is a redesigned version taken from the existing product in the market. Generally, the function of the hand winch stacker is to increase the storage capacity, where it allows a worker to stack the goods vertically on the rack or alternatively on both. Next, for product function are to increase the storage capacity and allow worker to stack goods vertically and horizontally. And the last one, we have product features. There are gear and cable steel for the lifting process, full flat base to provide a different height and wide lift range to lift the load until reach a maximum height, and last, handle to push the stacker. Next, problem statement. As we know, for the first stage of the first phase in conceptual design, which is defining problem, our teammate had a discussion about the requirement to design a manual operated material handling system that requires firstly, manually operated by one worker. Secondly, maximum load to handle weight at 500 kg. Next, system should be safe and provide speedy movement. And the last one is system should provide lateral and vertical movement for loading and unloading load.
For conceptual design, we have three different types of design that we have choose. Design 1, Design 2, and Design 3. Design 1. For this design, the stacker has a front and rear wheel. The stacker size is in medium size and it is heavyweight. It uses chain and sprocket system for the vertical movement. For the horizontal movement, it uses a slider. But this stacker does not have a support at the base. It only has a fork to support and lift up the load. Design 2. For this design, the stacker has a front and rear wheel. It has a larger size than Design 1 and it is also heavyweight. This stacker has handle but no support at the base. It uses fork to lift up and down the load. The vertical movement uses a driven gear attached at the back of the stacker. And the horizontal movement uses the same movement as Design 1, which is they uses a slider. Design 3. This stacker design has front and rear wheel. The size of the stacker is in medium size and it is lightweight. This design has handle and base support. It uses roller system with bearing for the horizontal movement. For the vertical movement, it uses worm gear and pulley to move up and down when lifting the load.
Okay, next is product chosen. Between those three conceptual design, our group decided to choose Design 3. The reason why we choose Design 3 is because it is lightweight compared to others. It also has support to prevent things from fall down, and it has handle to ease the worker to push the hand stacker. And as we can see from the slide, for horizontal movement, it uses roller system with bearing to move the things horizontally. Next, as we can see from the slide, the vertical movement uses worm gear and pulley system to move up and down during lifting process.
So, this is how the product works. There are three movements that are built from our design. The first one is vertical movement. The design created to move the load up and down. The second one is a gear mechanism, which is we use worm and gear mechanism to support vertical movement. And the last one is horizontal movement, which allow the load to move lateral, which is front and back supported by roller.
Next, we will go to the finite element analysis (FEA). With this, from the FEA, we come out with the stress analysis, strength analysis, displacement analysis, and safety factor analysis. So for the first we get in the FEA is stress analysis. With this, we can see in this figure, we get that the maximum stress of this design is 6044 megapascal, and with the minimum stress with this 0.3 nanopascal. And next is the strain analysis, which is we get that the maximum strain in this value is 0.03983. Next, we will go to the displacement. With this, you can see a two figure. With this one figure of the above, with isometric view, and the second is the side view. We can see it more on the displacement. So displacement occur after the applied load is 27.5 millimeter. Next, we will go to the safety factor. With this safety factor, we can see that the minimum safety factor after the applied load is 0.034. With this, as you can see in the figure, there is no red region. It's only yellow, green, and blue region. Next, we will go to the optimization of the product. As we can see in the before diagram, it says the handle are not suitable for this design. So we redesign it with this handle, with this at the after design, with it more suitable to use.
Okay, next is model of product. So this product consists of chassis, tire system, worm gear and pulley system, and also roller system with bearing. And for the design color, we use black, red, and yellow for our sticker. And for the material of the product, we use steel for the whole body and rubber and steel for our front and rear wheel. And this sticker need to be manually operated by the worker, and it can lift load up to 500 kilogram. Okay, next is conclusion. So, as a conclusion, the project can be considered as successful because we managed to overcome the problem stated in the problem statement, which is our product managed to handle weight up to 500 kilogram. Our product also can be manually operated by one worker. And this product also managed to provide lateral and vertical movement. And lastly, this product is safe based on the analysis that we run, and it is provide us a speedy movement. Okay, that's all from us. Thank you.